Machine Language Manager Cartridge by Bit Fiddlers, released in late 1981, early 1982 for the Bally Arcade Astrocade. Video Part 2, How to Use the MLM. This is the second part of a series of 4 videos for the Machine Language Manager Cartridge, a machine language monitor for the Bally Arcade Astrocade that allows you to program in machine language using hexadecimal and opcodes. In order to save with the cartridge, you require the 300 baud interface, although there is some information on how to save using the Astro BASIC cartridge with the built-in 2000 baud interface. Machine Language Manager, Overview of the MLM Manual. I have recorded myself using the Machine Language Manager, and I realized as I was watching some of the recordings that it would be good for me to show you some of the manual, maybe in a little more detail. I'm not going to show you the entire manual, it's really long, but I am going to show you, for instance, here's the cover of the manual. It's the manual itself, if you have the original, it's the cover is a hard stock cardboard, so it's pretty nice. I'm going to show you what the manual covers. This is the table of contents. There are a number of chapters as well as some appendices, or appendices, I guess, that have some really interesting information. I'm not going to really delve into the details here, but I am going to show you one section that's an appendix that has, actually it's not an appendix, I guess it's chapter 8, which is a quick reference. But here's what we're going to be covering in the manual, and some of this will be covered in the recording itself when I walk you through how to use the MLM. So chapter 1 is an introduction. It tells you a little bit about machine language. Chapter 2 has background information, tells you about the hardware overview of the Astrocade, which is very useful. And when I was first learning about the Astrocade, I found it very helpful to know. Then there's some Z80 specifics. These are kind of generic specifics for the Z80 that could apply to any computer in general. Conventions that are going to be used for the Z80. Hexadecimal tells you a little bit about that, and how an assembler works, which the MLM is not an assembler. As I've said before, it is a machine language monitor program. Chapter 3 discusses how to use the commands that are built into the MLM cartridge. Chapter 4 has some utility programs that you can type in. Chapter 5 is how to use the listing that's in Appendix A, or excuse me, Appendix A for references and how to learn machine language. That might be useful to you, but it'd be more useful to probably pick up one of the books or even reference the machine language, or excuse me, the nutting manual, which I talked about earlier. Let's see what else. Chapter 6 is the MLM routines as utilities. So if you're going to be writing your programs in the MLM and they were going to be running from the MLM exclusively, then you would want to pay close attention to this chapter. But since that's probably not how this program will be used, if you're going to use it like me, it'll be just to throw it in, check out something that you're going to type in real quick. Maybe you've assembled it earlier, and you just want to type in a short program of a few, maybe a dozen bytes or something like that, which is what I've done lately. Then you don't really need this chapter, but it might be worth perusing through. And the manual isn't that long to begin with, so you could read the whole manual from cover to cover, and it'd be all useful. Chapter 7 is sample programs. There's the Critter program written by Brett Bilberry. This version of it runs under the Machine Language Manager, and I'm going to actually load all of these programs separately. So Critter, the standard color generator, the 256 color display, and the ASCII character set. Plus, after I show you those programs, I'm going to show you one other program that's not included with this, but that was written by the Bit Fiddlers, called the Goldfish demo, and I talked about that earlier when I showed the source listing. Chapter 8 is this quick reference manual, and I'll show you that a little bit better in a minute here. Chapter 9 is useful memory locations. So let's get started here. I'm not going to cover this whole manual. Like I said, I'm going to pick snippets from it, maybe 5-6 pages, and the reason I'm doing this is because when I jump in to showing you how the Machine Language Manager works and I'm walking you through it, I found it's a little more difficult to follow than I thought it would be. I guess since I'm trying to make this appeal to someone who doesn't know anything about machine language or just a little bit, I thought it would be useful to cover some of what's in the introduction. Well, where he basically says that the Machine Language Manager is the equivalent of a front end to talk to the Z80, just like Bally BASIC is for to talk to the Z80, but in a different language. And he also recommends some books, which I talked about earlier. And so that's about I think that's the entire introduction. So now I want to step ahead here and show you the quick reference. Now these just show you the commands that are available to the MLM. And I'm going to explain when I'm using the program in a minute here, and you'll get to see me using it, is that you enter either a memory location and then follow it by a command, or you would have a byte, which would be followed by a command as well. For instance, on this first page, you can see that the top command that explains is the address command, and it tells you it sets the address pointer. I'm not going to go into detail about these, but I'm going to try to cover each one of them a little tiny bit. So you'd enter 4 hex digits and enter the address command, and that's going to be where your bytes are going to go if you start typing in bytes to the for opcodes. And an opcode is an instruction that the Z80 can understand. Next is the write command, and that is going to be 2 bytes. The read command, if you type that in by itself, it's going to read from an address. The insert command, I'm not going to go into detail about. It's kind of confusing. Read the manual for that one. I won't even cover too much when I'm showing you how to use the program. You can look at parts of memory by pressing 4 digits, which would be the memory location, and with the list key, and that would list many locations at once. You can also look at the registers. You can call a program that you've written, or even call parts of the utilities. You can also call utilities that are part of the Machine Language Manager. And you can write to tape, read from tape, and list what's on the tape. And that's similar to what you can do with Bally BASIC. And by the way, one of the last things it talks about here is reset. And it says it halts a routine that's in progress. And it does not erase what's in memory. So if your program crashes, unless it messes up severely, you can recover. And you can hopefully get back to where you were and maybe fix your problem. You can also do halts and things like that to debug, but I'm not going to go into that because that's kind of technical. Chapter 9 is useful memory locations, and some of these are pretty important to know. Others aren't as important, but knowing some single byte calls like CF for the breakpoint, like I just said, it's kind of hard to know how to, it's difficult to show you how to use it in this kind of a video overview, but it's useful. Clear is something you'll use, but these are not commands. So if you want to clear the screen, you can't just type clear and call or something like that. You have to type 2347 and call, and that would call the clear command. If you wanted to do a carriage return, you type in 2405 and do a call. That's how you would use all these useful subroutines. Then there are also kind of areas of the RAM that the Machine Language Manager uses, and some of these are useful to you. So if you wanted to, for instance, here 4FC6 contains the color list that's currently in use. You can actually change that yourself by just writing to those locations. The Machine Language Manager gives you a lot of power, but you have to know how to use it, and the manual does explain how to do it, but it takes practice, and don't expect to be able to finish watching this video and be like, actually, no, I take that back. When you are done watching this video, you will be able to use the Machine Language Manager probably better than if you just read the manual. But the manual isn't going to teach machine language to you, Z80 machine language. You will have to find another source to do that. But what the manual will let you do when you're done watching this video, and even just summarizing the manual, if you just read it quickly, you will be able to understand and enter machine language programs as opcodes and hexadecimal from a Z80 book that you use as a reference. And when you're first starting, that's actually probably better than using an assembler, because programming an assembly using a cross compiler like ZMAC, using a cross assembler like ZMAC, it's a little intimidating if you don't know what the heck what's going on. And it actually is kind of helpful to know what an opcode is and its equivalent is in a hexadecimal before you get started with assembly. So this is kind of, I won't promise you that this is the way to start learning a Z80 machine language, but it is definitely not a bad way to go. It's definitely useful knowledge. Everything you are learning in this video is useful to you as a programmer, whether or not you use a machine language manager. The last part of the MLM manual is made up of 45 pages that are exactly what the MLM source code looks like. In fact, it is the MLM source code. So it's written in the summer of 1981, or finished in the summer of 1981. Andy Guevara wrote it, and it's really handy to have. And back in 2002, I actually retyped in the source code and was able to make it compile and finished it up back in 2004. It took me a while, but it was useful to do, and I recommend you looking through it. Check this out here. This is the stuff that I retyped. This is just one page of it, the first page. What's useful is if you were to download this from Bally Alley and use a ZMac, you can assemble this program yourself. And what you'd end up with is a machine language listing, which is useful. And it's actually, when I said the last 45 pages of the manual are the source code, that's true, but it's also a machine language listing, so it shows you the bytes that are available. So, or not the bytes that are available, but the opcodes that are assembled. So if we are to look here at the at byte address 2000, you'll see it says C31020, and that's a jump, and it's jumping to a memory location 2010, and that's going to disable the interrupts. If you didn't understand one word of what I just said, that is okay. Then that means this video is for you. This is the source code that I retyped. This is just the first page of it. And this next page is the listing that is created by the ZMac cross-assembler that you can run under Windows or Linux that will create this listing. And so if you take a look, you can see that on the left-hand side, there are memory locations. And that is the difference between looking at a listing. If you ever decide you want a printout of the Machine Language Manager source code, definitely assemble that and print out the machine language listing. So that's enough about the manual. I'm going to show you now the steps to use the Machine Language Manager. If it feels like you're losing yourself and you have no idea what's going on, persevere, because you have to learn and start somewhere, and using this Machine Language Manager is a pretty good place to do it. Using the MLM, Section 1. What is the MLM? The startup screen. Usable RAM versus lines per screen. MLM keypad overlay. MLM commands. Address, write, read, list. When you first turn on the Machine Language Manager cartridge, this is what you're presented with. I have to say it isn't much. If you don't know what this means, then you're just going to be wondering what to do here. You just like the basic cartridge, you can't just go in there expecting to know how to use it. We do have some information awaiting us just from the screen right here. It's telling us that we have 140 bytes available, starting at 4E10. Of course, since this is machine language, it's really not 140 bytes, it's 0140 in hex, and that's equivalent to 340 bytes free. And that's if we use up the max amount of screen real estate. And the max amount of screen real estate is 39 characters across by 15 characters down. We can grab quite a bit of RAM back if we use less real estate. I'm not going to do that here. But 0140 is 340 bytes, and that's pretty important. It's good to know. As you can see, there's kind of a cursor. It's that white box, but it doesn't blink. It's kind of hard to know what it is. I guess the Atari BASIC, it looks similar, but I've always preferred a blinking cursor. And before we even get too started going through any of the list of commands, what have we got here? We've got the Machine Language Manager. It's for the Bally Arcade. It's written by the Bit Fiddlers. Their slogan was "Computer Products for Work and Play," which is totally correct. This one, I wouldn't say it's exactly for work. I mess around with it. I'm playing with it. But they also wrote some games on Cartridge as well. And we're not going to talk about those. We are here to talk about the Machine Language Manager, which from now on I'm going to call the MLM. This program was written, I think, exclusively by Andy Guevara out of San Diego, California. It's copyright 1982, but I think it was available as early as 1981. It was first advertised in December, I think the December 7th issue of the Arcadian newsletter, and it was reviewed in the next issue because someone had seen the ad, ordered the product, got the product, within 2 weeks wrote a review and submitted it, and it was published. A couple of people published reviews for this game, or for this cartridge. Now the Machine Language Manager cartridge is a Machine Language Manager monitor. Let's see if I can't get this right. It's a Machine Language Monitor. It's pretty primitive. It's only a 2K ROM, and it requires the 300 baud interface to actually save, which is okay. I think the longest program I've seen load that, and it took up pretty much all of the RAM, was about a minute and a half, which, hey, it's not instant. It's not nearly as fast as the 2000 baud interface, but it works, get the job done. So we're going to begin by trying out some of the commands. Hopefully by now I have talked about the table of contents and showed how it works. Oh, by the way, I'm experimenting. This is the very first video I've used using a headset. I'm okay. I'm pleased with it a little bit. I've tried using them in the past. They never have worked out. I've never even released a recording with them because there's so much noise. This one, it's not noise free. It's okay, and it seems to be doing a good job. So I'm going to jump right in. I'm going to skip the table of contents. I'm going to skip the introduction, and I'm just going to start using commands. So as I've probably already showed, there's a keypad over. There is a keypad overlay, and it's got a call, reg, list, insert, read, address, write, and an asterisk. Those are the only commands you have available to you. Everything else you're going to be programming is in machine language using the opcodes available to the Z80, which is hundreds of them. But you have to understand how to program in Z80 to use this cartridge. Or, even if you've never programmed in Z80 in your life, you can actually work your way through this manual. And I would make a bet that even if you've never touched machine language, you could read this manual and understand how to use it. The manual is extremely well written. You might not understand Z80, but there are some examples here in the appendix that show you how to type a program in, or there are program examples that you can type in, and they'll work. I'm going to show you how to load programs later, but I am going to show you how to type in a program, a short one anyway, here. But first, let's get started. The way the Z80 works is you talk to its addresses. Think of these sort of as the line numbers in BASIC. The first address we have available to us is 4E10. But we're going to follow the manual, and we're going to just type in an address of 4E54 because that's what it's suggesting to do. And so I typed in 4E54, I pressed the address key, and now anything I type afterwards is going to be available in that area of RAM. So I have, it's asking me to type in 11, right, 22, right, and then 33, right. This is nonsense. This is gibberish. Z80 doesn't know what that means. It's telling me this is what I see on the screen, and that the MLM puts a space in between each line in between each of the two numbers or letters that I type. And by the way, hexadecimal is 0 to 9, and then A through F. And each number or letter represents 4 bits, and 2 characters represent 1 full byte. That's about all I'm going to get into on that subject. Let's see, next is talking about how to read. So something I can do is I can clear the screen, and I'm going to do that right now. So to clear the screen, it's not as simple as you might think by typing clear. You type in a jump, or call, 2, 3, 4, 7. 2, 3, 4, 7 is going to clear the screen. And I type call, and there it is. I don't have a cursor. I can type reset, and I'll have a cleared screen. And reset with this cartridge does not destroy anything that's in RAM, which is pretty darn cool. And it's also a way to get out of a program that has crashed most of the time. If a program has crashed really bad, you can lose your program. So save often if you're programming in machine language or BASIC. So as I can prove to you right now, we just wrote to 4E54, 4E54, and type that again, and then I type address. Now instead of doing a call, I'm going to do a list, and it's going to list 8 bytes. And I guess I don't have anything there. Did I type in? Oh, I typed in the wrong number. So it's 4E54. So 4E54, and then list. And that's what I typed in. Now that was a great example of everything you do in machine language, in any programming language specifically, but machine language, I mean, it does not forgive. BASIC, you know, you might be able to get by 1 byte off in machine language and your program is hosed. So don't mess up. Let's see. Now what have we got showing? It's showing us how to do a list. So we can do, if we can continue pressing list here, we'll just keep getting 1 byte at a time, which isn't really too useful to us. But I'm going to show you something we can look at. Let's look at the very first bytes of the machine language manager. We can tell it the machine language manager begins at location 2000. Did I say enough zeros there? Or 8192 in decimal. But since we're talking to it in hexadecimal, we type in 2000 address. And I say list, and I press it once, and I get that. Now, if I want to, I can actually show more than one at a time. So what I'm going to do is I'm going to clear the screen. So I'm going to say 2, 3, 4, 7. Clear the screen. Now I'm going to tell it I want to list at 2000. So starting from 2000, I say that. Now I'm going to do a list all the way to 2068 because I happen to know, because I've done this already, how many lines will fit on the screen, which is 15. So 2068. I do a list, and it's going to list the first, I think, 14 or 15 lines of the Machine Language Manager cartridge, which, as you can see, is quite a bit. It's much smaller than you would get with a Bally BASIC. The font is nice and small. It's fairly readable. It's only 3 by 5, which is pretty tiny font. When I say 3 by 5, I mean 3 by 5 pixels. So we could go ahead and crash our program by jumping to 2000. You want to see what happens? I don't even know what will happen, but it's all forgivable because we can start over. So 2000 call, and it just says okay. How interesting. Do a reset, and we can actually look at various parts of the cartridge to see like RAM locations and stuff like that might, or excuse me, ROM locations that might be holding ASCII text. And I'm not going to do that right now, but I might show you that later.
Using the MLM, Section 2, Examining ASCII Text in ROM, Changing MLM Defaults, Debugging a Program, MLM Command, Reg.
It's always fascinating to take a look at some stuff that's stored in ROM, and we're going to do that since it's not interesting just to look at stuff that you don't understand, even though you can understand it if you break down the opcodes. We're going to look at just ASCII text that is stored in the ROM. The first thing we're going to look at is some stuff that's stored in the onboard ROM of the Astrocade. I'm not going to look at a lot, but just a few things. We're going to look at some of the text that's in Gunfight, and that is stored starting at location 1D70. We tell it we want to start there, and then we're just going to start listing. And that's I think all there really is for that. Okay, so here it says get ready and draw. Not too exciting, but it's a couple things. When
on the right hand side of the screen, next to the opcodes, or next to the hexadecimal digits, like they're not all opcodes. For instance, get ready isn't an opcode. You have breakdowns of anything that's ASCII. If it's not ASCII, it just puts a period. So it still takes up 8 bytes on the right hand side column. Now let's see, let's take a look at some of the menu messages that are stored in the onboard ROM. And those start at location 0D, I think C0. And no, I don't have all these memorized. I just happen to have looked some of these up to check out where they're at. So there's the gunfight message, the checkmate message, calculator. What else we got going on here? 1978 Bally. I think that's all of them. So I'm going to show you a few things. I was saying earlier that strings allow you to have, well, I don't know if I was saying this earlier. I've made a few videos. I don't know what order I'm going to put them in. Heck, this is just I used to get very defensive, like not defensive. I used to worry that these were going to be out of order and they needed all this editing. And I still tried to do some editing, but, you know, this is just for fun. And but if I in another segment, whether you've seen it or not, or you will, I wrote a 4-byte program that calls for a 4-byte string display program. Now I could have pointed that string display program to byte, let's see, 1, 2, 3, so 0DC89A. So if I were to point that program to 0DCA, why don't I do that? I can actually do that. So, well, I'm getting distracted. That's just like me. But what I can do is, that's something you want to do, is when you're writing or when you're using your machine language manager, you will be constantly writing down stuff. This is the way it goes. So I'm going to write down that 0DCA is the beginning of the gunfight message. So I'm going to write a short program here in a little while, very short 4-byte program that will display the gunfight message, which is kind of neat. But in the meantime, let's check out some messages from the Machine Language Manager cartridge. So starting at 2620 are some messages. So let's take a look what we've got here. Alright, that's quite a bit of text there. I think, okay, some of this might not look like it's text, but it all is. So one of the commands I haven't talked about yet is the REG command, which stands for registers. And you can actually, and this is one of the reasons I like this monitor, and maybe all monitors allow this, you can change the actual contents of the Z80 registers, and you can also examine them. I'll do that right now. But in fact, just for the heck of it, let's examine the register so I can give you an idea of what I'm talking about. Registers list. So this is the contents of the registers. The registers inside the Astrocade are A, B, C, D, E, H, L. And then it's showing the current address, which is being 2690, which is that's going to be like, so if I hit list, it's going to list from 2690. Which is handy to know. That's something to do with the MLM and not the Z80 itself. So what I was trying to get to was that it's starting at the 27 F0 list. Color bound. 27. Oh, that's I wanted to show that later. So here, let's go back to 2620 and list. The screen's getting kind of confusing, isn't it? Why don't I do a clear screen real quick, and which is 2, 3, 4, 7. I had to look that up, but as it turns out, I've already memorized it. So do a call. The clean is now cleared. I also can do a reset, which will probably run easier. So I want to do some text from 2620 address, do a list. So what's kind of cool here is that you are able to look at, let's see, the address on the left-hand side. Take a look at 2628. The first byte there is A colon. And so when you use the register, it's printing that to the screen. So so an A is 41. So look at 2628 line. In ASCII, an A is 41, a colon is 3A. And then the end, printing from a string, it's 00. So that's what you've got. So when the subroutine is called that prints the register, it grabs text from this area of ROM and throws it onto the screen. I'm not going to get into that too much, but I just thought it's fun to look at because it's something you can understand if you know nothing about machine language. Another pretty cool thing you can do is you can press a reset and then just call immediately, and it's going to start asking how many text lines you want on the screen. The default is 15, which is F. You can make it down all the way to 1, and which it wouldn't be useful, but I've tried 3 and it works okay. So I'd write 3 and write. The color boundary, I'm just going to say write and accepts the default. The background color right now is 00. I'm going to change it to 07, which is going to be white, I think. And then foreground is going to be 00. And it does a reset, and it also tells you where RAM starts again. So now I've only got 3 lines I can type on the screen. It looks a little more like BASIC. I don't actually like the way it looks now. I actually do prefer the black on white, or excuse me, the white on black. But this works pretty well. So as you can see, there's more RAM available, and now it starts at 42D0. And so we'll do 42 D0 and do an address, and we'll list what's there. And there's actually stuff there because and I'm only showing a little bit on the screen, so 3 lines maximum. That's the most I can see. So right below the 3rd line, I'm going to do a little bit of typing here. I'll do 4 3 0 8. I'll just start putting some random stuff into RAM. Put zeros. In fact, I'll just type random stuff. Doesn't matter. I just want to show that's the most. So right below this line is screen RAM, and that's where everything we're typing is being stored. I'm not going to get into that, but that's useful to know. And it's very useful to know for the MLM. I'm going to do a reset. I'm going to reset everything back to its default by doing a call and doing a write, and now everything's back to the default settings. So what are some of the other commands that we can use? I've got a short, quick reference for the MLM commands, and this is in Chapter 8. It's 2 pages. It's called the Quick Reference for MLM, and it shows you the address command, which we've already talked about, the write command, which we've talked about, the read command, which we've talked about. Let's see, the read command says returns a value of a byte at the pointed address, which is kind of, we'll do 4 E10 read. So I haven't really I've used this command. I don't use it often. I might as well look at 8 bytes at a time. So I would prefer, I would prefer to look at, so if I just keep typing read, it's going to show me all the bytes there. Let me get a program I wrote earlier, and we're going to do some modification to it. And this program is going to call the gunfight string. So now I'm going to say reset. I'm going to store my program at 4E40 colon. I'm going to enter the opcode DF. Don't worry if you're not following along here. It's what I'm trying to show you is how the program operates, not showing you how to not teaching you how to write machine language. The message for gunfight, hopefully this works, I haven't tried it yet. The message for gunfight is at 0DCA, so we have to reverse those bytes because that's how the Z80 expects it. So we say C and then A and 0D. it with C9. Oops. There's no backspace in this program. Alright, so now if I do, let's see if I can't call up that string 4E40. I guess I screwed that up, didn't I? That's what happens when you don't write good code. I did a reset just now. Let's check out what we have in memory. This is the big thing about machine language. You have to understand what's going on in memory. So let's look at our code. It's at 4E40. So we type in 4E40, write the address, we do a list, and I have my code, which is df, and let's see, df. Oh, I skipped a byte here, so I'm going to type that in again. 4E40. This is kind of helpful for someone who doesn't know what's going on. You can look at what your code you entered in and enter it in correctly. At least that's the idea. So we write our code. So that's going to be df, df, right? The gunfight code is at CA. And then 0D, followed by a C9 for return, and that should be it. So now if we type in the address, we can check it out and make sure that that's what's there, 4E40. And we will get the address. So there's our 4 bytes of the code. Let's make sure that 0DCA is actually for gunfight. So 0D CA address. Let's do a list. And gunfight starts at, oh, not quite there. It starts at 0. That's why it's not working quite properly, because I want to start a gunfight, so it's at 0DCC. So let's change 4E41. 4E41 address. We need to change it to CC. Yeah, CC. Now we'll look and make sure it got changed. 4E40. Do a list, and our program got changed. So now it's going to read, hopefully, from the correct place. Let's try running it one more time. 4E40, and let's do a call. And it says fight, so I screwed up something somewhere. Let's check out our, let's see, our RAM again. So 4E40, list, and we'll do, I guess let's see. So 0D CC list. So it did print out correctly. I just told it the wrong place to go. So it needs to go to 0DCDE. So 4E40. Well, I'm not going to spend too much more time on that. I'm not going to debug a program while you watch. How boring, right? So what else haven't I covered yet? So we have the insert command, which I'm not going to cover at all. It's a little confusing to use, so I'm not going to cover that. Something this monitor is lacking, and it should have, and maybe there's a way to use it, but it's not it's not obvious to me, is it a copy from one area of ROM or RAM to another area of RAM, and I don't see a way to do that. There might be a subroutine that does it. Let me check real quick. These are the subroutines that are available to you, but they don't really talk about in the manual how they work too much. You'd have to actually look into the machine code, and then it tells you. But the subroutines that they say are useful are clear, carriage return, green, red, norm. So like green will let you print in green, and then red. You can print an error message. You can print a space. These are all subroutines that you don't have to write yourself. You can just call them from within the machine language manager. You can initialize ripple interrupts, get a key, display the contents of the A register, scroll the screen. You can set up breakpoints in your program, which is pretty cool. And there's specific locations in RAM that are, I think sometimes they're called hooks. Like in BASIC, I think that these would be called hooks. But you can move bytes. So maybe the last moved byte would be something we can mess around with. But I think that's all I'm going to show you. There's plenty of other stuff I'm going to talk about. But that's all I think I'm going to talk about on in a tutorial. So let's see what we got here. Anything else in the manual? We've got calls, which we've covered, the registers, which we've covered. I guess I should cover the register in a little more detail. So when you press the register key, you can change what's in register, or you can just list what's there. So if you press reg and list, that's what's there. If you press register and change anything, if you press reg, and let's say you want to change what's in A, let's change it to 01, and then you press right. Now we can, and if you continue to press list, it just accepts the defaults. So now we can say register list, and it should be a 1 in A, which is handy. If I was to print a character, you print whatever a 1 is, but in ASCII, I don't think that's anything that's printable. I think, let's see, let's go through this a little bit more. I advise you, if you're even a little bit interested in this, check out this program. It'll work on emulation. If you really want to write in machine language and you have an Astrocade, get a RAM expansion and try using the Blue RAM utility. That's useful. Or the best way to write in machine language for the Astrocade is to use a cross assembler and write cartridges. But something I like about the machine language manager, I wish they'd called it the MLM for machine language monitor, but they didn't, is you can use this live. So you can check out what's in the registers all the time. You can check out what's in RAM all the time on real hardware. I like that. Let's do a reset. And everything's in RAM still. See if there's anything else I want to look at. Oh, I guess I should talk about, if you wanted to, you are able to save to 2000 baud. I've not messed with that.
Using the MLM, Section 3. Using the MLM machine language listing. Using a system routine. Using rectangle. Typing in example 5-1. A splash of green.
Chapter 5 of the Machine Language Manager Manual is called Using the Listing as a Source of Information. So the manual includes like 45 pages of the source code listing in Z80 for the Astrocade. So that's pretty crazy. I like that. I was able to type this in several years ago and actually assemble the program to be byte for byte compatible with the actual ROM dump of the cartridge. So it says here that there's a lot of good information there, and that if you can understand how the program works, it'll help you to write good machine language programs, which I believe is true. I don't really understand how it works, but I kind of get the idea of how Machine Language Manager works. I like it. Let's see. One of the things it talks about here, which answers one of my earlier questions, is you can use the move byte subroutine to move bytes from the Machine Language Manager, and that's built right into the Astrocade itself. Well, that's kind of cool, so I guess that's handy. I'm going to type in a short program that uses an example of how to paint a rectangle to the screen, and this is a really short program. It's let's see, 1, 2, 5, about 10 bytes. I'm going to type it in, and it's going to print a green rectangle to my current cursor location. And it's doing this by calling the rectangle subroutine through something called the system sentinel. And I'm going to do that right now. So I'm going to enter the program, and this is just another example of how to program, or not program, but how to use the manager itself. It's not teaching you how to program, but if you're interested, this is on page 5-1 of the manual. And we're going to start at the location 4E40. We press address, and then we can start entering our code. So we're going to load the BC register with the size of our rectangle, which is going to be 0503. So loading the BC register opcode is 01, and I do a write. The next, then we tell it it's going to be 3 by 5, so we say 03 write, 05 write. Next, we're going to load the A register with the mask, the color mask, which is FF. So the opcode for load A is 3E, right? And we're going to enter FF here. So that's going to make it green because that's how we have our color register set up. Next up, we're going to load the DE registers from the coordinate location that's kept in the ROM in the manager, or excuse me, in the RAM from the machine language manager, which tells the current location of the cursor. So that is located at RAM location 4FC3. And the manual explains this. If you're interested, check it out. But so load DE is going to be ED, then write, and then 5B. Let's see, 5B, and then our coordinate is 4FC3, which we write in reverse order. So C3, 4F, and then we're going to call the system sentinel, and we're going to do FF. And the cartridges all make heavy use of this, and so have I when I've done programming. We're going to call the routine, which is at location 1C in the ROM of this Astrocade. So we tell it 1C. We write that, and now the routine is done. We're not. That's called. There's a syssuck and system calls, and this is a system call because it's expecting everything to be in BC, A, and DE when you call the rectangle subroutine. So we have to end with a return from the subroutine, which is C9. Great. I think I messed that up. I actually didn't press write, I pressed address. So let's see, let's do registers. Let's actually check out our program, 4E40. So 4E40 address. Let's do a list. So yeah, we need to put C9 after the 1C. So at 4E489AB. So 4E4B, we need to put a C9. Once you start using the machine language manager, this will make a lot more sense. And like I said, don't be afraid to jump in and just try it out. You don't need to know machine language when you get started. No one knows machine language before they start, right? So now let's check out that the program is correct. 4E40, and we'll list it. And it should be 01, 03, 05. So far, so good. 3E, FF, that's great. Then ED, 5B, C3, 4F. Then we're calling System Sentinel at 4E49, so it's FF there. And the system rectangle is at 1C, followed by the return. So now if we call this, we're going to, at the current location of the rectangle, excuse me, of the cursor, we're going to get a green rectangle. So let's try that out. So we type in 4E40, 4E40, do a call, and ta-da, it worked. We finally got some color going on the screen, so isn't that nice? I think I'm going to stop there for now.
Using the MLM, Section 4, the User Program Interface, UPI. Fill. subroutine hex 1A. Now, why would I be showing you the cover of the software and hardware for the Bally Arcade, a technical description manual here? I've showed you this before, but I don't think I mentioned that this is also the manual usually referred to by Astrocade users as the nutting manual. And it's a collection of all the routines and how they're called and how to use them that are inside the Astrocade. Now, the Machine Language Manager cartridge mentions this by name kind of in its own manual, but it does say that there are some routines that it could not fit into the 2K available to it. And if you ask me, some of those routines probably should have been included, like fill or move or copy. But the manual does say that these routines are available in the Astrocade's ROM, and you can use them from there. However, that's a little confusing for a beginning user, so I'm going to show you how you would actually call one of these routines. But before I do that, I'll show you how it works. So like I said, this is the cover of the manual, and the first one that we're going to cover, the first routine, is going to be a fill. So this would be used to fill an area of memory, RAM, with a byte that you want to fill it with. In my case, I'm going to fill it with 00, which would be just to empty it. And you'd call it using the UPI, which is built into the system ROM, which is the user program interface. I'm not going to get into details of how this works exactly. Basically, this does a restart of the Z80, calls a certain area of the system ROM, and it will call the user program interface when you do a reset. So when the user program interface is called, you now have access to a whole bunch of subroutines that can be called quite easily and used very easily for machine language anyway, from your own program. And this includes from your machine language manager. And it's so easy to use, in fact, that like the programs that I'm going to show you in order to fill and copy routines are only 3 bytes long. So is that even a program at all? Really, not really. But I'm going to show you how this works. So first up, here's page 16 that contains the screen fill, which says it fills a continuous area with a constant. And like I said, this is going to be filled with, we're going to use it to call 0, or we're going to fill it with the RAM with 00. Notice how there's a calling sequence and arguments. So we're going to be not using the sysuk, which is SYS-SUK. That's actually the way I prefer to use it if I'm doing assembly language. It works, I think, a little easier, and it's easier to understand when you're going through your code. But if you use the system way to call, which is what we're going to do, then you just give it arguments that are going to be in the registers. And so we're going to fill our registers with a data that we're going to fill with. So we're going to give it a 00, which you'll see. We're going to have the number of bytes we're going to fill, and we're going to put that into a register called the BC register. You don't know what registers are? That's okay. The manual explains them very overview, but you're just watching this. Enjoy yourself. The DE register is going to hold the address to where the 00 in our case is going to be moving to. This is routine 1A. How do I know that this is routine 1A? Well, the home video game library, which is included as part of the source code in the nutting manual, has a listing of all of the routines and things like that, and has the numbers of them. So here's a picture of the retyped routine as it was retyped in the early 2000s by the Bally Astrocade group, or Bally Yahoo group. And there's a couple of us, or several of us actually, who got together and retyped the code for the header file and for the entire AK of source code. But you don't need to use that for the Machine Language Manager cartridge. But you do need to know the routine numbers. And the easiest way to find them is in this listing. So here's what the listing looks like. And I've opened it up. And if you check it out, I have highlighted here the fill, which equates to routine 1A. Technically, this is in the source code is considered number 26. And if you figured that out in hexadecimal, that is a 1A. So that is how we will call it. We'll call the UPI by calling FF, and then we will pass the 1A to it. So this is my actual source code for the routine that I wrote. I mean, really, I didn't need to write this. I did this mostly so I could just show you, and you can see what I'm talking about here. If you look at my code, it looks a little complicated, especially if you've never seen machine language before. Don't run away. Please don't. Stick around, because if you look here, we're not actually going to be calling the program this way. This would make it a little complicated, and it would make the program more difficult to use than it needs to be. So we're just going to call or type in 3 bytes into a free area of RAM. It doesn't really matter where we put them, and because this program is so short, it's not calling anything. It doesn't matter where it's located in memory. And if you look here, this highlighted portion here, you'll see that FF, 1A, and C9 are the portions or the opcodes that you need to type in. FF isn't technically an opcode. It is how you'd call the system subroutine. So really, if you look up FF in a listing of opcodes, it's going to be a restart. And in this case, it's doing a reset 3.8. That's not important. You don't need to understand how it works. All you need to know is if you put a FF, follow it by another hexadecimal number, the hexadecimal number is going to be a routine that it's going to try to call. And since we want to call the fill routine, as I already showed you, that's routine 1A, and that's it. And we're going to then return back to the machine language manager. So that's a return, so C9. So when we type on our program, which I'm going to show you next, we'll be typing in FF, 1A, C9, and we'll be calling it, and that will do a fill. Check it out.
2 commands are conspicuously missing from the machine language manager. One of those is the fill command, and one of them is the copy command. The machine language manager says you can use routines that are built into the Astrocade to substitute for these missing commands and other missing commands as well. And so I've written 2 short programs, I mean really short programs, if you can call them programs at all. They just basically call the commands that are built into the Astrocade's ROM. The first one I'm going to use is I have my blue RAM plugged in, and I'm going to show you that it starts at the 6K area. So let's check it out. And there's random garbage in memory because it's unpredictable what's going to be there. So the first thing I want to do is fill that in with all zeros. So the blue RAM is 16K long, so it runs from, let's say, 6K to 9FFF, and I want to fill in all of that with zeros. So if I'm going to look at, just to show you that it goes all the way to 9FFF, I will show you that. So 9, let's see, FF0. So you can just check out what's at the end there. And it's garbage. We are going to change that right now. We are going to use a small routine located at 4E10, which we're going to put in right now. 4E10. And the routine is simply FF, which calls a system sentinel, 1A, which is the fill command, and C9, which is the return command. And that's our entire program. So if we want to make sure that it's actually there at the beginning of RAM in the machine language manager, then we'll check. I just wrote it there, 4E10. And there's the program I just wrote. All it does is FF tells it to call the system user routines. 1A is the fill routine, and then it returns from there, and that's it. However, you need to give it some information that's going to be stored in the register. So right now, let's see what's in the registers. We've got in the A register FF, the B C register FFF, the DE register. Well, I don't need to tell you what's there. You can see it's on the screen. This routine uses 3 of the registers. It uses the A register to hold what you're going to fill with. I'm going to put a 0 in there. It holds the BC, or it uses the BC register for the number of bytes that you want to fill. And it holds the DE register is going to be holding the destination address, which is in this case is going to be 6K, which is the beginning of the blue RAM area. So first, we're going to call it the register. So I press the register key, and I'm going to put a 00. So I type 00 and then write. Next, it's going to tell me what do I want in BC. We'll put 4000. So like I said, that's the number of bytes we're going to fill, and that is 16K. And then DE is going to be 6000. or it's not really 6000 technically, it's 6000 because it's in hex. HL doesn't matter, so we'll just say write, and so we've got everything we want. We have a 00, a BC filled with correct, so now we want to call our routine. So for E10 and call. It's done. It's already back. You didn't even see it disappear. It doesn't look like anything happened. But if we are going to look at the beginning of the blue RAM, as you can see, it's all filled with yeah. So that's that. I'm going to show you now how to do a move routine.
Using the MLM Section 5, the User Program Interface, UPI, move, subroutine, hex 5E, also known as copy. Next up, we're going to be using the move routine that's built into the system ROM. This is also going to be accessed through the user program interface. The move routine is called move bytes, but really it's a copy routine because it doesn't change the source. And what we're going to do is, this is on page 65 of the nutting manual, and it describes how the program works. This is routine 5E. Also, we know this from the home video game library a header file, and we need to call this routine having already filled the registers, 3 hit register pairs. The DE register is going to hold the destination address where we want the information to go. HL is going to hold the source address where the information that we want to copy is, and BC is going to hold the number of bytes that we're going to transfer. It's as easy as that. Here's my program. I wrote this again just basically so I could make sure that my program worked properly. Here's the listing, and here's another version of listing with the 3 bytes that we need to type into the machine language manager to make sure that this routine works properly. So we're going to call the system routine. We're going to pass it the move byte, so it's going to be 5E, and then we're going to return to the machine language program or machine language manager by doing a return, which is C9. So here we go. Check it out. Easy peasy.
Another feature that isn't available in the MLM cartridge is a copy command. And there's actually a command built into the system ROM called move, but it's actually really just a copy because it doesn't delete the location that it's moving from. So we're going to use that in order to move the MLM cartridge to the 6000 area of the blue RAM, and then we're going to put the blue RAM into a cartridge mode and take out the machine language manager and run it from the blue RAM. So how do we get started with that? The program we're going to start, and we're going to put it in location 4E10. So first we'll start telling it this is where we're putting our program. And so now our program is simply the move command. So we're going to call the system interpreter. So FF, then 5E, and that's the move command. All of this is available in the nutting manual if you wanted to look it up. And there's actually other places you can look it up too, but that's the most convenient one. And so that's our whole program. So let's make sure it actually is there. So now we're going to look at location 4E10, address, do a list. There's our program. So the FF stands for call the system interpreter, which the Bally Arcade understands is really a reset 3.8 in hex, and which jumps to the system interpreter in the ROM. And 5E is the move. So then once the system interpreter has been called, it's going to call the move command, and we need to now load up the registers with what the move command wants. And the move command is going to want to have DE used, HL used, and BC. Those are the 3 registers, or register pairs technically. It doesn't use any other ones, like A isn't used, for instance. So we're going to load DE. So first we have to say register, then we're going to say write, which just puts whatever was there. BC is going to hold the number of bytes we're going to move, and we're going to move 2048 bytes, which is 2K, which is the entire blue RAM manager cartridge, which is just a 2K cartridge. So we're going to say 0800, and that is 2K. Then we're going to in DE, we have to put the destination address, which is 6000, which is the first byte of the blue RAM, and that goes so 6000, and we write that there. And HL is going to hold the source, which is going to be the first byte of the cartridge area, which is where the blue RAM, where the machine language manager is held. So 2000, right? Now we can see that's what's there. We can do it once more, and it automatically tells us. So what's important here is that BC is holding 0800, DE is holding 6K, and HL is holding 2K. Now if we run our program, it's automatically going to go there. The cartridge is going to be moved to the blue RAM area. So let's call it for E10 and call, and our program is already done. I pressed call and it is done. How can you tell? Let's first look at the 2K area. We'll list a couple of lines from it. And then we'll list the 6K area. We'll list a couple lines from there. And as you can see, it's identical. So starting at the at the 6K area is the machine language manager, and we just copied over one portion of ROM over to RAM. We could have, of course, copied RAM to RAM, and that's probably most useful. But this is just an example of how it works. So I'm going to actually hold down the reset key, switch the switches on the blue RAM to the ROM state, and change its range to 2K, so it'll act like it's a cartridge, and I'm going to eject the blue RAM, I'm going to eject the machine language manager cartridge from the cartridge port. So I'm holding down reset currently. I'm switching over the switches, so now it's in ROM on the blue RAM, and it's telling it it's a cartridge. I'm pressing eject. I'm still holding down the reset. You need to do that the whole time. Now when I let go of the reset, it's just going to say OK, because as far as it knows, it still has a cartridge in the slot, and that is it. So that's an example of using the copy command. Currently, I have no cartridge in my Astrocade, but the blue RAM is acting like a cartridge because I use the copy command or actually I use the move command, which is built into the Astrocade's system ROM, to move over the 2K to the blue RAM. It's as simple as that.
Using the MLM, Section 6, an MLM single byte call. String, print string. Here I'm going to give you a short description of the string display program that I say I wrote it, but it's so short I didn't really write it. I'm just basically using a utility that's built into the machine language manager that lets you print a string. I guess it's not a utility, it's a subroutine. But before I do that, I want to clear up some things. I've been making this series of videos for the Machine Language Manager for about 2 weeks. So the various videos have been recorded at different times. And I've noticed a couple of things as I've been starting to put this video series together, that there's a few, I wouldn't say they're super important details. Some people might not even notice them. But one of them is that I continuously seem to refer to restart and reset, which are used in these programs that I've been talking about interchangeably. And they're not really interchangeable, but when I say reset, and I'm going to say it in the upcoming video, and I've been changing them and fixing them, I'm not going to do that anymore. Basically, if I say reset and I'm talking about like an FF command or DF opcode, just know that I'm talking about restart. Most people don't even know probably what I'm referring to. They overlooked it. And for those that have, that's my fix. Also, earlier examples sometimes didn't match my machine language listings. For instance, if I wrote a program that resides at 4E40 and RAM, I might actually just type it in at 4E10. And that's because these programs are so short that they don't care where they reside in memory. They'll just run, and you can put them pretty much anywhere and they'll be okay. This one, the program itself doesn't matter where you put it, but it refers to a string, so that always has to be at the same place. So let's get started. I'm going to start this a little differently. Usually I show you the machine code last. This time I'm going to show it first. So this is the program. This is what I call the string display. It is going to basically take a string and put it on the screen. Unlike the previous programs that I were showing you that are not built into the Machine Language Manager, The string display is actually built into the Machine Language Manager. You just can't call it directly. In the Chapter 9, the useful memory locations, it is considered to be just one of 3 single byte calls. And it's a single byte call because of the way it is used and the way it uses the restart subroutine that's built into the Z80. And I'm going to give you some details about that just a little bit. You might not follow along if you don't understand machine language, but for those that do, this might be some interesting background on how the Astrocade handles restarts. And for those that don't understand this, it's still kind of interesting material because, well, it might not be as interesting to you, but it's only going to take a minute or 2 to talk about. So how about that? All right, so here's the program. It's on the screen. It's basically a restart, and it jumps to an area of the ROM that's in the Astrocade, and then it goes to, and it pulls out an area of RAM, or excuse me, well, yeah, in this case RAM, and it's going to print out ballyalley.com. When I'm actually typing in this program, it was going to be like a surprise, I guess I thought, what it was going to print, but it's not a surprise. It's just a string. I was originally going to try to, and I mentioned this, I was going to make it just say hello world, but I thought that was boring because it's been done a million times. And I don't know of any computer program example that uses ballyalley.com. So here's my program before it is, oh, actually, I guess this is as it's been assembled. Here's a close-up of it so you can get a better example. This one has been highlighted. What you see in yellow is all you have to type. So, of course, like the previous programs, you don't actually have to type in like restart 18, define word, website, return. That would be something you type into an assembler. Here, we're going to type in DF704EC9, as you can see on the screen. Here, the ones that are highlighted next to 4E40. So I'll repeat that. What you would type in is what you see next to the RAM addresses. So 4E40, you type in DF. So next to 4E40, you see DF, which is a restart 18. So you type that in. And you would continue down the line until you type in the 4 bytes. Then you have to tell it where you want the string to be saved. So you'll tell it you're going to start writing to 4E70, and you'll type in the ASCII codes for www.ballyalley.com. This program works differently. This is not a built-in subroutine of the Astrocade. However, it does require the Astrocade's ROM to understand what's going on. So back in about 2002, the Astrocade's machine language portion was retyped by the Bally Alley Yahoo group, and it was worked on and off for a while until it was finally in its current form, which is, I guess, from 2004, so it's already been around for a while. Now you can tell it, when you assemble it, it can assemble into any of the 3 various ROMs. That there's one in the white Astrocade, which is a little bit different, and I'm not going to go into detail about those, but just understand that what you see here on the screen, this is the first page of the listing for the machine language portion of the Astrocade's internal AK ROM. Here you see the second page, and there's going to be a small portion called the jump through locations to cartridge restart vectors. And I'm going to do an extreme close-up in a second, but just let it be known that the Astrocade allows the programmer to restart to different parts of a cartridge, and that is what the Machine Language Manager does in order to print its string. To sort of give some background for someone who might be interested, I've highlighted this section of code. This is at location 0018 in the Astrocade's system ROM. When the reset vector is called for the print command in the, or not the command, but the print subroutine that's going to be loaded from the MLM, it jumps to this location. And when it jumps to this location with the restart vector, it gets redirected to location 200D. And when it does that, that 200D is part of the MLM cartridge. Here is the first page of the MLM's source listing that has been retyped. What we need to look at is not on this first page, but it is on the next page. This is location 200D, which we want to look at. So, of course, since it's important to know what's going on a little bit, if you're interested, you can probably skip the next minute or 2 if you're not. Here's a close-up of location 200D. And that simply does a jump to the label string display, which is STRDIS. This is highlighted here, And so the C3 next to 200D is a jump, and it then jumps to location 23B5. And if this sounds all like gobbledygook to you, sorry, we're almost done. One more little page to talk about. So here is a close-up of the machine language listing of the machine language manager, and this is location 23B5, the start of the string display. And the way the string display works is it grabs some information from some registers. It also grabs the location of the next character that's in the string, puts it on the screen, and if it's not a 00, which is the end of string marker, then it keeps picking up strings until there is a 00. And that is how the string display works for the machine language manager. It's simple, but if you can tell here, I'm going to count the bytes as you look at the screen here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes is how many bytes you don't have to use in your own program. Now, is that important if you're writing a program in a cartridge? Not so much. It is important if you're going to be writing a program and you only have like 320 bytes of RAM, which is the most that's available if you have 15 lines of code on your screen when you're using the machine language manager. So now I'm going to show you how to type this program in to call the string routine, and after that we're going to wrap things up.
As an example of how to use the machine language manager, I have created a program which I call string display. I made this just today. It's very simple. I base it on a program that's actually inside the machine language manager cartridge, or in the manual. And this is a simple 4-byte program that's going to display a string that I came up with. I start the program at 4E40, and my string is going to be stored at 4E70. So the first thing I need to do is tell the machine language manager where my program starts. So I say 4E40. Now I type the address key. So the next few bytes are going to all be stored from 4E40 to 4E43, which is enough room for 4 bytes. My first byte is DF. Now that opcode for that is, well, DF, but the mnemonic for that is reset 18, which is going to automatically jump to 0018 of the system ROM, and 0018 of the system ROM, which is built into the Bally, is automatically going to do a jump to the cartridge, whatever cartridge is in the Astrocade. In this case, the cartridge that's in the Astrocade is the machine language manager, and so it's going to jump to that, and what that space is on the machine language manager cartridge is the string display is actually it's a jump to the string display that's built into the machine language manager. It's a pretty neat, efficient little system. So now I'm going to tell it where my string is stored, which is at 4E70. And when you are actually typing in opcodes to machine language for the Z80, you have to type in the high byte second. So I have to type in a low byte, and I'm storing it at 4E70. So I type in 70. I write that byte out. I write the high byte, which is 4E, right? And that's my entire program. Now I just have to return to the machine language manager. So I type C9, which is the return, and that is it. So now I have to tell it where I'm going to put my my actual string. I'm not going to tell you what the string is. You'll see soon enough. It is going to be stored at 4E70. So I say 4E70. I say address. Now the rest of everything I type now is going to be at it's going to be stored at this address, which is my program is calling. So if you look back, the second byte I typed in was 704E, which is this in reverse, this address in reverse. So first I'm going to type in a few letters here. I guess there's going to be about 10 or 15 characters, and I hopefully don't mess any of them up. So that is 20 is a space, then 57, space 57. And after each I type these two numbers, I type in the right key. So 57 are two ASCII characters, or 57 is an ASCII character, which I'm entering 3 times, and I'm following that by another ASCII character. And I'm not going to tell you what this says. You'll see soon enough when I run the program. It's not very exciting, but it's amusing to me. And no, it's not going to say hello world, which I was going to do first, but then I thought, I can do something better than that. Let's see, hopefully I'm not skipping any characters because I'm talking and probably not paying as much attention as I should be. But hey, if I mess it up, that'll give me a good excuse to try to correct it. Although my experience so far with this editor, or not an editor at all, is it? With this monitor cartridge, is that it's, I've already lost my place. Okay, so alright, yeah, it's easy to lose your place, especially since I'm not wearing my glasses. And I'm almost done. What have we got going on here? So some of you might be wondering why the heck I'm not playing with my Astrocade and say using Wizard of War, which is a nice little cartridge I could be using. But I enjoy doing what I'm doing. Okay, now that's my entire string. However, all strings and have to end with a 00 to tell it to stop reading. So now I have to put in 00 and right, and that is it. So what I can do, so you can check out what I've got going on here, is I can show you the program, which is at 4E40. So I'm going to say 4E40, and I'm going to now say address, and I'm going to list it. And that's it. That's my program. Actually, only the first 4 bytes are. My string is at 4E70, so let's check that out if it's actually got there. 4E70, and let's list that out. It actually, that's a good thing to do. So now you can see what it actually says. It says, let's say if I typed it in correctly, I did, because it shows 8 bytes per line, and if it's any of it's ASCII, which in this case it is, it actually shows you on the side what it says. So the cat's out of the bag here, and it says www.ballyalley.com. So let's run the program. So I'll type in the address and do a call to it. Or actually, let me clear the screen. I'll do that first. And there's a built-in clear screen command that's built into the Machine Language Manager. And it'd be nice if it was just clear, but you have to do a call to location 2347. But it will clear it the correct way. I mean, there's other ways you clear the screen, but this will keep the variables the way they're supposed to be. For like if you can change how many lines you want on the screen to get more RAM and stuff like that. So I'm going to do a call to 2347. And call. So now the screen is totally clear. And you don't get a cursor, as you can see. The screen is totally black. So now I need to tell it where I want the program to run from. So I type in 4E40. I type call, and there is my my program. That's all it did. It automatically will put it at the current quote cursor location, even though there's no real cursor. So I started it off with a space, and that is it. Hope you enjoyed checking that out. It's pretty fun to look at for me. And as I was saying, it's not for everyone programming on the Astrocade and machine language using this monitor cartridge, but it gives you a taste of what it's like. It also kind of puts you back into that time period in 1979 or so, or even a little bit later, I guess 80, 81, to show how people who didn't have an upgraded Astrocade but wanted to program in machine language could do that without using BASIC. And this is what they would have had to do. This would have probably been the easiest way to do it without an upgrade. In fact, it definitely would have been the easiest way to do it without an upgrade. So if you get a chance, visit this website. You'll have a ball there.
Using the MLM, Section 7, saving a machine language program with the 300 baud interface, no tapes, using WAV files, saving, loading a machine language program, checking a program, and running a program. The Bally Machine Language Manager is a pretty useful product. One of the downsides of it is that it is unable to save without the 300 baud interface. Compared to the later 1981 re-release of Bally BASIC, as seen here, which has the audio cassette interface built right into it, there is no easy method to save to tape using 2000 baud. There is a method described in the Machine Language Manager which involves popping out this cartridge here, or actually popping out the Machine Language Manager cartridge, popping this cartridge in, and then saving that way. I find that to be awkward, and there's quite a bit of risk, it seems to me, in order to lose your program. So I use the original method. The original method to save to tape, as is done with this original version of Bally BASIC, which does not have the built-in 300 baud interface, because one doesn't exist at the time. Instead, as I've shown you before, it uses this 300 baud interface, which is it was originally designed for Bally BASIC. It came with some demo programs that were saved in 300 baud BASIC, and this hooked in to your, at the time, this was a pretty generic tape recorder. A lot of times these are referred to as shoebox recorders, and it would hook into your hand control port number 3 and the accessory jack, which was, I think, really considered a light pen jack, but there was never a light pen released for the Astrocade, although some handy users did create their own. So the 300 baud interface would then plug into a tape recorder, and you could save from Bally BASIC that way. In our case, we're going to be using this interface with the Machine Language Manager cartridge to save as a file. This picture here shows a package of 10 90-minute cassette tapes that I just happened to find on eBay for I think it was like $15. They were brand new, and this is how someone would have saved back in, the 1970s, 1980s, and I guess maybe even the 1990s, but it is not an efficient way to do it, and it takes a lot longer, and it's kind of frustrating. These 90-minute cassette tapes weren't really used too much back in the original days when people were using tapes. They were using tapes like this example. This is a 60-minute tape, probably low quality, inexpensive. Even better would have been these 10-minute cassette tapes, because then you don't have to fast forward and rewind as much. You could get these relatively inexpensively, and they would you could fit 1 or 2 programs on there in 300 baud, and you wouldn't have to always be fussing around with figuring out where your programs were on the tape. We, however, are going to avoid that altogether. Why would we want to use tapes nowadays? I am going to be saving in this example to Audacity. I'm not going to show you Audacity in action, but here's what it looks like. This is an extreme close-up of a demo program that's for the Machine Language Manager. This is the 256 color demo. I mean, this is zoomed in very, very close. You don't have to be familiar with Audacity in order to save to your quote tape. When I say quote tape, I mean to a WAV file. You can use any program that will save in a non-compressed format. If you save an MP3, it's not going to probably work properly to get your program back into the Astrocade. This example that I'm showing here is zoomed in, like I said, very closely, but also the waveform is maximized because this program has been digitally archived. I'm not going to show you how that's done. I'm not going to show here how to use Audacity. I'm just going to show the steps as seen from the Machine Language Manager. It's up to you in order to hook up your computer to the 300 baud interface if you decide to use that, if you have one, or at least follow through, and maybe you can use the manual in order to save to 2000 baud cassette, which I have not actually done myself. And again, you wouldn't save to tape using the 2000 baud method. You'd still save to a program like Audacity, which is a free program, which is why I'm using as an example here. A lot of people use it to do podcasting because it's free. It's pretty high quality. I enjoy using it a lot. It's really easy to use. It's and if you don't understand how it works, there are many demonstrations on YouTube and articles written about this program. It's also available for multi-platforms. You can get it for Linux, you can get it for Windows, you can get it for the Mac. And if you don't like it for some reason, there's probably something that came with your computer already that will allow you to save to a file. And when you're done saving to a file, I consider that a raw format. Usually you're going to have a low amplitude, so you're going to want to adjust the file and amplify it, and then you can say load it back into the Astrocade without trouble. If you really are interested, you can digitally archive anything you save from the Machine Language Manager. There are a number of 300 baud tools available that can convert the raw format used by the Astrocade, which I'm pretty sure is the Kansas City format that came out in the 1970s. The primary program that I use for Bally BASIC is KCS. I have not tried this with the Machine Language Manager personally, but I'm pretty sure it has been used with the Machine Language Manager cartridge programs, and with good success. If you're interested in trying that, that's beyond the scope of this video by far, actually, but it's quite possible to save your program in a perfectly digitally archived format and then or load it back in yourself. So up next here is how to use the Machine Language Manager to save and load a program in 300 baud format.
I just finished clearing the screen, and I have my string display program in memory. I'm going to actually save it to tape right now. I've already tried this, it works fine, but I want to do it sort of here live to show you how it works. So in order to save, you have to type in like if this was basic, you'd write :print, and here you write you shift and do write. So I'm going to press the asterisk, and I'm going to say write, and that is going to take and put it into a mode where it's sending data out to the tape. So now I need to start recording, and just like in 300 baud basic, once you start writing out to the tape, now I'm recording, so I should shut up. So now I need to tell it what I want to put out to the tape. So I need to do area 4E 40. Say address. Now I say list, and so that just got written out to tape. Now I want to write out my string, so I type in 4E70 address, and I'm going to have to write out 3 lines. And that is it. Now in order to stop it writing out to tape, I type in the asterisk and then write again. This time, instead of getting a red a T for tape, I guess, it shows me a green one, which means it's no longer sending out data. So what I do is now I recorded this using Audacity. I'm going to amplify the entire thing because it's a little low, and let's see if I get it back in. I'm actually going to let's see, should I turn it off? Yeah, I'll turn it off. I've now lost my signal. Okay, we're back. I've recorded my string display program. Let's see if I can recall it back. So in order to recall a program back, what I need to do is I need to tell it I want to read it. And it's similar to the write. So I type in asterisk, read, and press play. And basically everything you saw me do a moment ago, which is what I typed, just like in Bally BASIC, the same thing happens. And this program is not digitally archived, it's just the raw recording. But as you can see, it does work, or it seems to be working anyway. Hopefully it does. We'll find out in a minute when I try to run it. I'm not sure exactly how long I recorded for, but it's probably, since I'm experimenting and talking, this is taking longer than it normally should. You can probably record most stuff in about 40 seconds. A good example of a long program would be the program with the goldfish demo, and that takes about 1.5 minutes. So I am done. It took about 56 seconds there, and let's see if I can run it. So I'm going to first clear the screen. So to clear the screen again, it's 2, 3, 4, 7, call. I want to press reset, But even pressing reset, it does not erase RAM in this program. So let's see if I can look at the program. I'm not going to run it, even though I'm sure it would probably run, but we can look at RAM and see if it actually got there. So the program is stored at 4E40, so we're going to tell it, let's look at that address, 4E40 address. Let's list it, and there's our program, DF704EC9. Now we're going to now check to make sure the string got into the correct place. So that's at 4E70. We type address, and let's do a list. And as you can see, it does say www.ballyalley.com. And we're going to clear the screen. I won't even bother clearing the screen. I'm just going to call the program. So the program starts at 4E40, and we do a call, and Shazam, we have it. That is the ballyalley.com program, or the string display program as I have it saved. Next, I can probably try to digitally archive this using some tools available from ballyalley.com, but I'm not going to do that during this recording. But you can try that if you are interested.
I hope you have enjoyed learning how to use the Machine Language Manager a little bit. In part 3 of the series, I'm going to show you 5 examples from the Machine Language Manager Manual. First up will be Critter, a program originally written by Brett Bilbray and published in the Cursor newsletter in 1980. Then there's going to be a standard color bar generator, which was also published earlier. Then there's going to be a program that puts all 256 colors on the screen at once, which is pretty neat. It requires machine language to do this. Then there's going to be a very short program that will display the ASCII character set. The next thing I'm going to show is the Goldfish demo, which was originally released on tape. The fourth part in the series, which I'm not really sure how it's going to work out yet, but I'm going to show you how to use a keyboard that's been set up for the Machine Language Manager and how that can be used with the MAME emulator so that you can emulate the Astrocade and still use the Machine Language Manager. I hope that you have enjoyed this 2-video series so far, and I look forward to being able to make these next 2 videos.